molecular form. If we can spray in the molecular form and we can deposit material one or the other, we can make 3D objects. That was his idea. But he didn't. He wrote a paper, but he didn't. He cannot able to make a setup for making that thing. Maybe years after that, this Goldwald, he has another brilliant idea. Suppose inkjet printers were very common at that time. So he used he thought about this technology. Suppose like an inkjet printer. Suppose if we can deposit metal drops, metal in the molten metal in the shape of drops, and one above the other, similar to the inkjet printer, then we can create 3D objects. So he tried to make a setup for that, but it was very complex, and it was a partial success, but he could able to demonstrate it. So that was a contribution from him. This Hideo Kodama, it's a community in Japan. So what their thought process was, there is polymers like a photo hardening thermoset polymers. So when light is intensed on, normally it will be in the liquid state. When light is intensed on this polymer, what will happen is the solidification will happen. The cross-linking will happen, and they will they will make the thermosetting polymer. You can get the solid part. So if we can control the incident light, or if we can focus the incident light to such a way that we can get a 3D model of the parts we want. So this was their idea. Okay, they could able to make some machine, but they are also partially successful. In 1980s, this was a critical milestone in this 3D printing era. Stereolithographic process. Stereolithography, if you go to any of the CAD softwares, you will know there are plenty of file formats you can save it, right? If it's a Trio, you will save as a .part file. If it is a SolidWorks, it will be in the STL file, right? No, STL, SDPL file, right? So SolidWorks. So there are in CAD, it's a CWG file will be there. So if you take for any of this thing, if you click on this drag down option, you will get a .stl file. STL actually stands for stereolithography. So in a stereolithographic process or stereolithography, what will happen is, suppose if I take any object, what they will first do is triangulate the whole object. Whole 3D object will be approximated with triangles. Now, if I have a triangle and if I am putting in a plane, and suppose if I am slicing it parallel to that plane, so what kind of things we will get? We will get the intersection of the plane with the object we have. We will get the boundary at that plane, right? Boundary, and we also know that where the material lies. So these two information is taken. Means we know what should be the boundary, and we know where the material is there. Okay. So what their idea is, suppose if I have this data, the boundary and this thing, so then we can have a photo curable resins are there. It's the same like a photo hardening material. Photo curable thermoplastics are there, where the light is incident. They will the photonic reaction will trigger the polymeric long chain of the polymers, and they can make the part will get solidified. Now they use this STL file and they used this normal CNC controllers to control the incident light, and made 2D scanning will happen. And then what will happen in the scan places where the light is incident, that will get solidified. Then they will drop down the platform, and again one more layer of the polymeric resin will be coming, and then again they will scan the second layer. Like that, by layer they are depositing. So this is known as stereolithographic process. After 10 or years or so, our Scott Crumb invented this fused deposition modeling with the polymers. Okay. Thereafter, large number of processes have come. Some of them have come, and now they are in the mature stage. Some of them are already obsolete and gone. So there are the pace in which this technology was developing was very rapid. Okay, very high rate, means you can say that a hell lot of researchers were going on this field from there. Okay, so this is a very brief of this technology. Okay, many other processes have come, and I'm not going to the details. You can always search for any other details. Now you might be knowing that there are plenty of processes which can be termed as additive manufacturing. So I have listed a few. It could be a fused bed deposition, binder jetting, material extrusion, material jetting, sheet metal lamination, and wet polymerization. So I will give just a glimpse so that you will understand what the process is and what kind of technology we can call it as additive manufacturing, or what kind of materials can be used for this one, right? So just I will give a just a schematic or this glimpse of it. So first is VAT polymerization. VAT polymerization, even though the term is different, it is the same as that of our stereolithography. So you can see that a liquid resin bath will be there, and over which the laser head will be there. We will control the laser head with the STL file data that we have. We know where to scan, and then we just control the X and Y motions on the laser, so that we will control the places where it has to be scanned. So whenever the scanning, the light scanning is happening, it will get solidified. Then again they will drop down this platform, so that another layer of material will come, and it will stick to the previous layer when the the scanning is happening. So it's very simple process. It's also known as stereolithographic process, and it's just another schematic, a functionable schematic kind of thing is there. So you can understand what the process is. It is very simple process. Now the second process is the metal jetting. Metal jetting is similar to the normal inkjet printers. So the raw material will in the droplet form, or it can be spread as a wire and melted it there, and they will just spray or just deposit the material wherever we want the solid part to be. Okay, and also if it's a polymer, we can use it UV radiation to cure it. So another schematic will be like this. So it is just like a printer in a 3D form. Okay, just by dropping the material where we want it to be solid. Okay, so this is a type of scanning which is there. So this is known as material jetting. Another thing is binder jetting. Binder jetting is our raw material will be in the powdered form. So a powder layer will be laid first, over which we will liquid in a binder in the liquid form will be poured. So the binder will detect what will be that part. As in the STL file, we know the boundary, right? So the boundary information is given, boundary and the material information is given by the liquid. So wherever the liquid binder is there, it will stick to the powder which is there, and over which another layer of powder will come. So this binder is nothing but an initiator to start or catalyst to start the bonding reaction or the chemical reaction which is there. So the polymers will have a cross-linking, and then they will create this kind of 3D object. So one layer of powder will be there, another layer of binder will be there. Then it will be like a sandwich. Alternate layer will be of powder and binder will be there. And now means once it is completed, then you can remove whatever it's in the powder form which is not been binded with the liquid, and then just shake it off, and you will get the solid part, and the rest of the things will remain as powder. Okay, so that is known as binder jetting. Another thing is material extrusion. It is the same. This is the process which is also known as fused deposition modeling, or we call it generally the 3D printing. The fused deposition modeling, or you can see that in this material, generally the material will be in the spool form. Material spool will be there in a wired form, in the wire, and there will be a nozzle and a heating element will be there. In that thing, when the heating is happening, our wire will be melted and it will be deposited. It is like a paste, and we can just deposit wherever we want. Okay, and this will be controlled by our normal CNC controllers, or any kind of controllers. We can do the for the positioning and accurately depositing that thing. We can control that thing. Okay, and this is almost 80% of the total machines that you can see in the field of 3D printing or additive manufacturing. This will be either this. It will be this kind of 80% will be coming under this material extrusion, or you can say that fused deposition modeling. Okay. Now moving to powder bed fusion. Powder bed fusion in this thing, generally our raw material will be in the powder form. So the most common thing is the selective laser sintering. Selective laser sintering was the term which was known as rapid prototyping earlier. That was a technology which is used by the aeronautical industry and the automobile industry to make this thing. So what will happen is the powder will be in there, and the laser head will be there, and it will be scanning. But the laser will be scanning, and then wherever the laser will be incident, that will be it will not be melting. It will be getting into an elevated temperature, and it will stick to the previous layer. Okay, so the reaction will happen, and the photo assisted reaction will happen, and it will get solidified. and where the scanning is not there, it will remain as powder, and after that we can shake it and get it. When it is means if it is if we are doing for metals, so metal can also be done with the same process, similar process you can say, and then we will use the laser melting. So in the terms of metal, then you have to give high intense laser is used, and metallic powder will be there, and we can scan it where our parts to be melted, and it will take it will be it will not be that much fast process. So melting, after that it allowed to solidify. Then again another level will happen only after minutes or hours. So it will be a slow process, but still it will be a very good means it can be used as a direct part, not as a prototype. Direct parts are made with this kind of process. When it is it cannot be beams, we can use another heat source. Then it is known as heat sintering, selective heat sintering, and electron beams are also used for this thing. So where metallic parts are generally done with electron beam, where you have the high temperature is there, high temperature is created. Then direct metal laser sintering means the same process. You will only sinter the part, the metallic parts only, but you will sinter. Then the compaction is required. Then only we can get the part. So direct means you can directly make the material. We don't have to have any other operation to do that. Okay. So this is the powder-based fusion. Another technology is the sheet lamination. So our raw material will be in the sheet form. So we can cut it using a laser or another sharp edge thing. So you can cut it. If it's a polymer, you can cut it with the normal knives also. So that will be controlled with the axis plot, means XY plotter will control that motion where the cut has to be made. And now when the cut is there, a sheet is there, right? Now how can we attach this sheet to the previous one? So that is done with, if it is a metallic parts, it is done with ultrasonic vibrations, and the ultrasonic this thing is applied. And if it is for a polymer thing, even normal heating roller will be sufficient. Or means it will be rolled over the thing, and it will be slightly heated up, and then it will stick to the previous layer. So this is the sheet lamination. So this is one of the things which is very advanced one, but this is used for metals only, metals and ceramics kind of things. And this is generally now we see that okay, our control is only in the scanning of XY plane, right? But this has rotary axis also, so we can deposit the metal from any side. So the complexity is more for this process, and it is mainly used for, suppose if something is worn out or means maintenance has to happen, we can use kind of thing. We can deposit the place where it is worn out, in a complex way, in a complex control is there. Okay, so that is, these are the processes that I would like to. This is also now the schematic is only for 2D, but it can be done for 3D also. Okay. Now these are the processes. Now let's talk about what kind of materials or how we can, means now we know the technology, right? But if I want, means without any knowledge, a person who does not know anything even can make 3D printed objects. Now how can be done? Because it's very simple process. So just whatever we can create in a CAD now can be printed. May not be in the size that we require, but in a miniature form, whatever capability of your machine will detect what is the maximum size that we can produce, right? So how can we do that? We just make the model in a CAD platform, just save it as an STL file, and this can be loaded to your computer, and the rest of it will be done by the machine. So you don't have to bother about anything. Suppose if I want to make the same part of machining, you can know about the things, means headaches that we have. You must know about the processes, you must know about the machines, you must know about the capability of the machine, you must know about the what are the things which has to be done before and what other things has to be done after that. But here, no worry about anything, just make the part and feed it to your machine, and machine will do the rest, and just after cooling and curing, you will get a 3D part. So this simplicity in the process made it very acceptable to the common people even. So many of the industries have adopted this technology for making their parts for themselves. Okay, now let's learn about what kind of materials are used. Many of them I have already told about, but as a glance, the main producer for this from 3D printed parts are plastics, thermosets, thermoplastics, and these plastics are also in different forms. It would be in the wire, it's as a wire spool or a powdered form or in a pellets or anything could be there. And now our now our 3D printing machines are capable of processing in any form. Means you don't have to be it need not be that you should be having a wire spool only. Those kind of things can be happen now. And advantages for this polymers or the plastics are they are very cheap, very easy to mold, and finishing is not required. And places where we know what kind of where we have this kind of flexibility. Means this is a very versatile material. Flexibility is also there for making or molding and remolding. So reuse can also be done. So that's one of the critical material which is used in 3D printing as well. Okay. Now the metallic 3D printing. So this is means maybe if in 10 years back or so, it was only in the trial state, but now we have 3D printed, directly 3D printed parts which can be used for machines. So our technology is now reached that level. Okay, so you can see that suppose if I want to make a block like this, which that man is holding, so how much time it will take or how much effort will take? An expert has to be there to make that mold, and then they have to cast, then have to machine and clean it off. Then they have to again the processing for the heat treatment, all those things has to be done, right? But in this go, just make the CAD model, and you don't require any experts to do that. You don't require any other process. Just in a single go, we can do it. Maybe it will take some time, but it will be much faster than what we are doing for the conventional mold making. The things advantages for this thing, so for metals also, but still it is in the developing state. We have not matured enough, but still many parts have can be done now with 3D printing. Now the ceramics, you can see that ceramics manufacturing is always a skilled labor kind of thing, because even in the prior ceramics era started even on the prehistoric ages, where man you can see some of the ceramic right ruins. Now you don't be an expert in ceramics. You don't be an expert in controlling the heat or the moisture or anything like that. Now any ceramics can be made with 3D printing. So that is the beauty. Now if I want to make a sculpture, just model the sculpture in any of the CAD form and just make it with the 3D printer. Now it can be, we can get the smooth finish, or you can. You might be wondering why these things are not there. So what these things are, these are the ruins, and what they make is they will scan these ruins, and they will make a point cloud data, and they will get the CAD model out of it, and again they will reproduce it with this 3D. Those reproduces of the ancient history, historical ruins are shown in this figure. Okay, don't confuse with that. It will not give you a good finish. No, it's not like actually the purpose is different. Okay, and also the actually used scaffolds are mainly made of 3D printing. I will tell you about scaffold when I go for the next slide. So next is the biomaterials. The biomaterial. This is a huge leap in the field of bio or medicine or in those kind of things. Why? Because now even though it is in the research state, people are now capable of manufacturing things with biopolymers. Biopolymers, it could be like chitin or fibrinogen or kind of things, collagen kind of thing. Suppose now even there are many success stories have reported, but still it's in the trial state. But we have also some certain success stories, like the thing in the third figure, which is that white thing. That's actually the trachea of a child. So which is a 3D printed model of the trachea. This is actually implemented, or with the surgery, it was put inside the body. It's not a prototype. It is not a part to be tested. It is an actual implant, which is now still with that child. Child is living with this thing. Okay. Now you can think about how matured we are in terms of in this technology, and also many of the other features can be done. Now, suppose if we can make our means if the bio materials are going in this phase, and if it can be 3D printed, now you can think about an artificial heart or artificial lung or an artificial kidney, which is made with the similar materials as that of what it is really made of. What our heart is made of, with the similar material, we can make a heart, an artificial heart. Okay, this is the flexibility, or this is the place where we are now. Okay, so this technology can make means nearly anything, but there are some exaggerations are also there. But don't think that you can make anything. But when the technology will advance, maybe after a research of 20 or 30 years, then we may be in that position. Okay, so biomaterials are also now capable of 3D printing. Now let's list out certain applications. The main the promoter of this this kind of technology is the aerospace industry. Why? Because this process is much faster. This process will give you the flexibility. Suppose if I want to make that complex structure using the conventional machining process of that, I'm talking about a turbine blade. Okay, you will wonder how much effort is there, how much energy, how much in terms of cost is there. So, but if that can be done with a simple process in a single go, that will be very beneficial. That's why majority of the 3D printing development is happening with the big players in the aerospace industry, like GE. They are coming up with many processes, new processes. They are coming, not new machines, and they were advancing in this field. And many of the previously done parts are now manufactured using 3D printing. They were very adaptive to the technology, and they are promoting and they are funding for this technology. One of the critical factor why they do is because from this figure you can understand the weight can be reduced, the material can be reduced, the size can be reduced, the assembling can be reduced, number of parts can be reduced. So now you can see there are number of parts in that with the different materials. So every time if I want to make a part, it will take a lot of time, and a lot of manufacturing has to happen for every part, and a lot of energy is used. A lot of things are going to be waste. But if you can do it in a single go, if single part can do that purpose, then it will be very easy. And here you don't have to be worried about many other things. Just make and do it by you. Okay, the machine will do it. And also, don't think that this simple part. Even now, you can make mechanisms, working mechanisms with 3D printed models. There you just have to play with the tolerances. If we can play with the tolerances to such a level that we can make really working this mechanisms which can be directly put into your machines. Those kind of things are now capable. It was means this kind of exercises are given to us when we were in MTech. So at that time itself, it was means we were not the first to do that. Many years back, the people could able to do that thing, mechanisms with this kind of thing. So assembling, if assembling is eliminated, you are saving in terms of time and cost. A lot of money is invested in only for assembly, and manufacturing number of parts is reduced, means you are saving a lot of money in that way also, and you are making it very faster rate, right? So this is the beauty of this technology. That's why people, aerospace industry is adapting it very fast. Now you are capable of making a drone by your completely 3D printed drone is there, completely 3D printed gliders are there. Maybe we will get a completely 3D printed flight maybe in the future. Not only the outer skeleton, but also the parts inside that can also be done with 3D printing. Okay. The second application, the second most user of this thing is our automobile industry. The things which is given as in green, that is already there. Means now those things are manufactured with 3D printing, but the dots shown in blue, that is the future. Future means it is not, it will come later future or 20, 30 years back. It is already in use, but it is in the testing state and certification. Means when a new technology is coming, then there will be some time will be taken to adapt that technology, right? So adaptation time is there. Maybe after 5 or 6 years, many of these parts will be done with 3D printing. Maybe after 20, 30 years, you can maybe majority of the parts which is used in a car will be 3D printed. That could be the future of this technology if it's going if it is developing very rapidly. Okay. Now, as I told you, this is for the consumer goods or the product development, there will be always some fight between these two sections. One is designers, one is manufacturers. So designers want their design or their product to be aesthetically good. They want it's very beautiful, that aesthetic appearance has to be there, texture has to be there, many other complex things they want it to be embodied in this thing. So then only they stands for beauty and perfection, right? But the manufacturers, what they will do for, they want it very simple. They want the machine, the design to be very simple. Why simple? Simple parts are simple means we only have a limited number of manufacturing processes. Either we can cast it, we can form it, we can weld it, or we can machine, right? Suppose if I want to have a complex car, you might be knowing how much difficult it is to make. It will be there, but it will require a lot of time, and it has to be there. Specific control has to be there, or if it's a man-made thing, then an expert has to be there. So every time there will be a cost associated with any of this complexity. Even one complexity I'm talking about. Now, if you think about the plenty of complexity, if it is there, then what will happen? So they will have always a clash between these two departments in an industrial firm. But with this technology, now we don't require any expert to do that. Now any kind of complexity can be accommodated. If I want a ball to be inserted in a ball, inside a ball, possible. Any level of complexity it can accommodate. Any kind of closed loop shapes or difficult to manufacture surfaces, possible now, right? So that was one thing. Another thing is now you can custom made your work. So this, you just look around your room where you are living, and think about how many things are there that you have designed for yourself. There will be nothing, right? Everything that we purchase from somebody else's design. If I like it, I buy it, right? It is never like, okay, I want to buy something which in this form. Maybe we will search for that. When we get it, okay, then we will get it. Otherwise, we will leave that dream into a dream. Now, if I want this as a representative, if I want my shower to be from a dragon's mouth, it is possible. Just make the model and give it to any of the 3D printer shops. They will 3D print it for you. Very simple, right? I want this bottle to be with the material that I want, with the specifications that I want, with the size that I want, holder with the whatever shape and size I want. Now it is possible. So this is the flexibility that this technology has given for the designers and manufacturers or the product design field. Another thing is we already talked about rapid prototyping. So the number of in a product life cycle, we have to come up with many designs before it's actually going to manufacture. So we'll come up with many designs. So that design means to realize that design, this technology is very helpful. Also not for just for designing it, for testing. Suppose if I want to make a big bridge like this, if I want to do the internal testing or how it will perform with the different loading situations, we can always simulate and we can just see the real testing can be done with this kind of models. Another huge boom is there in the functionally graded materials. Different materials can be clubbed together. So our parts will be like, if I want to do two materials together, we will do the assembling. Now assembling is not required. We can make functionally graded parts, which will miniature your size of many of the parts that you are using in your future. So this is for the consumer goods industry or for the product development. Now another major leap should be in this field of biomedical equipments and biomedical things. Now I told about a term like scaffold. Scaffold is nothing but, suppose if a bone is missing or a bone is gone, or a part of some bone is broken and it's gone. Then what will do? Bone cells itself have the capability to replicate themselves and patch. They will patch by themselves, but it will require some certain medium is there, and also the support has to be there. For making that support, we will put some porous structures for giving that support. So that is known as scaffold. So the scaffold manufacturing, now you can think that suppose if it is a scaffold for our skull, then you can think that all our from person to person it will be different. And even with the person, if I take the curvature for different sides, then it will also be different, right? So custom manufacturing is required. But if I manufacture customly and if I design it for the custom manufacturing, it will take months to make a single scaffold. But this technology, within hours, I can make it. The porous structures with the mainly this is done with the ceramic materials or the metallic materials, which is biocompatible. and this can be done very easily. So this is one of the examples from the bio. So that's just to give a glimpse. Okay. Moving further, now I have many of the places I have already told you about the advantages, but just to summarize what are the main advantages. So the complexity of the design is now no longer it's a problem. Any complex thing, if it can be made in the 3D platform in a CAD, now can be manufactured with 3D printing. It is very cheaper. When I say cheaper or faster, it will be very contextual. Suppose if it's a complex part, if I compare the part with the normal manufacturing thing and then compare with the cost for doing it in a 3D printing, then it will be cheaper, right? But if it's for a simple part or a normally produced part, then it will be the other one will be the cheaper. But so that's what I say when I say all the properties, it is very contextual. Okay, don't think that this is very cheap. No, it is not so cheap. But compared to the other things, if it's some complexity is there, then it is very cheap and faster as well. We already know we can reduce number of parts and the number of assembling, and assembly itself can be eliminated if possible, like a kind of thing. So it's a very fast production, and number of assembling can be reduced. Accessibility is there. Now we know that the process itself is very simple, and we don't have to be an expert to do that, so that any common man can do with this thing. So it's accessible to all. Anyone with the 3D printing means you don't have to be an expert. If anyone with a machine, if they can know how to CAD model it and put that thing in your computers, then it will be easy to manufacture. So you don't have to learn about any technology. Then consistency and quality. Yes, it will give you consistent thing, but quality sometimes we can also debate on that. Sometimes it will give you better quality than normal. Sometimes it will be less. But one thing is sure, number of processes can be eliminated, so that it will give you the consistent quality. That is for sure. Okay. Now weight reduction that we have already seen for that thing, and product life cycles. Yeah. Now since we can prototype it very fast, we can come up with a good model, with acceptable model very fast, so that we can eliminate the in between time, or we can save the time for that. So new products can come very fast, and also we can learn from the faults that now existing products is, and now we can always improvise our product, and our product life cycle will be reduced. Okay. Now tangible design. Yes, that's the beauty of it. Whatever we can make, we can see it and feel it, and also it can be used for testing. So this is one of the peculiar thing which is with 3D printing. They make the tangible products. And risk reduction. You can see that our normal manufacturing process, the risk associated with it, it will be in a noisy environment. It will be using hazardous chemicals. Hell lot of energy is imported for heating and cooling, and our processing, and the hazardous to the people which is working, hazardous to the environment. And always, whenever I talk about this environment, it is very our normal manufacturing process is very polluting. But here, I'm not saying that this is a good process, but still, it is and also you can see the waste which is created is much higher. Means 80% of the total part which is going to be used is going as waste. Only we are using less than 20% for actual part. Okay, but here we are using 80% is going to be in use, and only 20% is going as waste. So the risk factor is also there. So that is all. And also I want to tell you about some one more point, but I will tell you in the end only. Now the future scope. As I already told you, now you can think about our heart or lungs or kidney or anything or liver, which will be made of 3D printed object, biocompatible object. Not only that object, it will be similar to what our real heart is made of or lungs is made of, if the materials in this field is matured enough, or we can able to do it with 3D printing. So that will be one of the future scope of this technology. We might be very near to that thing, because many success stories are now coming up. Using bio materials, we can make artificial implants and kind of lungs or limbs. Okay. Second thing is this one, construction. This is not a scope. It is already there. In 2013, China made its first 2-story building with 3D printing within 2 days. 2 days is the time for making a house which is 3D printed. So the technology that they are using it, they will having a feeding mechanism of the bricks, and what they do, they will plan a layer of bricks, then they will over that they will they will pour the layer of or cement mixture, then they will put that them and compact them and make that thing. So it is similar to our binder jetting, right? Similar to that process, they could able to make a 2-story building within 2 days, right? In 2013. Now, apart from those technology, now we can create with ceramics and the building the things which is used for building. We can use the same materials to make our own building with our own whatever curvature or whatever fascinations that we can design it with a 3D printer for our house. We can literally we are creating our own house. Not the designer is creating for us, not the architecture is creating for us. We can make it. So that's the beauty of this technology. So that will be the future. Now the cost of building is getting very higher. So we have to use this technology. The labor cost is also getting higher. So maybe in the future, we will not be using any labor to construct anything. We will use 3D printer to construct anything. So that could be one of the future. One of the trends is happening in this field also. This is a cool technology. Now, if I go to a shop for my shoe, there will plenty of model will be displayed. I have a size for my, so it could be US based or a UK based, so I say 7 or 8 or 9 or something. Then they will show me the things. Means sometimes it happens that I have a good design or a better design for me, but that size for my size it may not be available, right? But our future retail that will be clustered. There will not be separate things like will be there and it will come from the fact and tailor will sell it. No, it will be like you will go to the shop, you will not see this price. You will only see 5 or 6 printers will be there. So first of all, they will scan your feet. So they take the point of data from you and they will exactly model a 3D model out of that data. Okay, that will be fed to this thing. Now you can custom make this thing. What material that you have to use? What kind of purpose it is yours? What should be in my size of my sole? What should be my size of the envelope? What should be the height of this thing? All the things that you can give the it will be like in the screen you can fill by yourself or somebody else will be taking those data for you. Now within an hour or two you can make a custom made shoe for your feet. It is only fitting for your feet. Sometimes it is not necessary that only one feet can be scanned because both has to be taken. Sometimes there will be slight difference in your geometry of your one feet and the other feet, right? That also will be taken care of this thing. So this is also not a concept which is there. Nike and Adidas are now coming with this kind of technology. The only thing is the material science is not matured enough to do that for all 3D printing. Otherwise, it would have been done come by now. Now you can think about what kind of factory or what kind of retail shop you can expect. Not only in this field, many other fields is adopting this kind of technology as a shop. Means you don't have to be hello, some disturbance. Okay. So you don't have to be means there will not be anything. Means you can select your own model. You can give your own shape. You can your own color. Means whatever it is for you can be made with custom manufacturing. Okay. Another thing is 4D printing. 4D printing is just it's like a 3D printing only. Only thing is whenever you think about fourth dimension, what will it be? Generally, the answer will come as time, right? Science change that it will be time. So here also the fourth dimension is time only. So we can create certain 3D objects, but with the time the shape changes. Okay, or it could not be the time. So it will be the circumstances can also affect. Suppose if I'm putting it in a elevated temperature or temperature difference can also create the time means the geometry or shape change, or it could be the pH, or it could be electricity, or it could be anything, any environmental factor can change this time. So this is happening in the actually the advent is happening not the field of 3D printing. 3D printing technology will be the same, but the materials that is going to be in the 3D printing is different. That's why we can get this kind of 4D objects, which will change over time or over the circumstances. It will change its shape. So also in in a future ornament, some of the already made things are I have listed it, and if you Google searches, you will get plenty of diagrams and plenty of things which is manufactured in 4D printing. Okay, this is also some useful objects are also there. Okay, now our food processing industry. Now you can think about different. If I want to make food is not only about taste; it's also about the appearance, right? So you can now create any kind of shapes by 3D printing. Similarly, you can make any kind of food products with 3D printing. So you can think about, suppose if we have an oven, I want to make a cake. So you can, there is an option to put the ingredients. We can control the ingredients. Now we can custom design the cake with the colors that we want, with the aesthetic appearance that we want, and beautifully it will be arranged. We don't have to do anything. It will be automatically done. The oven will be there, and there will be nozzles for putting the materials, and we can compose the material and get the real food product. So food processing industry is also using going to use this technology dividedly. Now this is all I want to tell you about this 3D printing. Now this will be my last slide, and I would like to tell one thing that is already listed here. This is why I like this technology. This is let me give you a brief. I was working on the field of sustainability. Sustainable manufacturing was my topic of research in my PhD. But so what I find out is that whatever means manufacturing will not cope with the environment. So whenever we manufacture, we create problems. We are creating a hell lot of problems that we may not be able to solve it by ourselves, right? So that much in a bad manner for the environment we are doing. Sustainability will not stand only for the environment, so it will take care of the people. So as I already told you, we are means the machining or the manufacturing processes are happening in the hazardous environment, not only for the people, also for the surroundings, and planet is going to be affected with mainly from this kind of technology. And also they are using excess, huge amount of energy is used for manufacturing, very huge amount of energy. And now we are living in the world of energy crisis. Now, when I talk these kind of things in front of an audience, many times I will get a question that, do we have an alternative? But many times I fail to answer this question. But because I don't know, means what I will tell is, as a escape mechanism, I will tell, what I tell is that we can optimize the processes already that we have. Means we can optimize the processes. Now it could be machining or casting or anything. We can optimize the things so that the waste can be reduced, the energy can be reduced, or we can move towards sustainability. Sustainability, I will always say, as it's like a perfection or a heaven, where we don't know what it is, but we can always move towards that. But now this question made me very uncomfortable, asking that whether we have an alternative or not. Then I go to dig out certain journals, and I understand that there is a term which is known as biomimicking. Now you will understand what is biomimicking. See, our human species is relatively new, very new, but we already know species which have lived for thousands of, not thousands, millions and millions of years in this world. Okay, those creatures are surviving because of some adaptations. Whenever the climate changes, whenever the circumstances changes, they adapt to the situations. So they are solving problems much complex than that we are facing now. So they are ultimate problem solvers. Now, if we have a problem, why don't we look them, how they have solved the problem, and learn from the nature, and those kind of things could be termed as sustainable, because nature has a balance. To keep that balance, whatever in a possible way, it does, right? So why can't we learn from the nature? That was the principle behind this biomimicking. So this lady, Janine Benyus, so she had a talk in the TED also, and many other talks she have. She is a veteran in this field of biomimicking. So her idea was to understand the problem and try to correlate with the similar problem which the other creatures are doing. Means other designers are, she called them designers or the problem solvers. So learn from them, because they have the experience for millions of years. Now what we have is the experience of a lifetime. That's all, right? So it is better to learn from them.
Now, in that she also mentioned a thing in that talk about this shelled creatures, which we call it crustaceans. Crustaceans, what they do, they are not born with the outer body, means the crust or the shell that they have. They create this kind of shells. Why they create this kind of shells? They don't have any vertebrae. They are very prone to the means. There are many predators will be preying on them, so they want to protect them. So they want to create an environment which will protect themselves, right? So most of them might be living in the ocean, or some of them will be living in the means other than the oceans, in the our normal water bodies and all. You can see crustaceans, right? Now, how these people create these, not people, these creatures create this shell, and you might be wondering that some of the shells that they create is much stronger, and the hardness is twice as that of a human could possibly make, or the thing human could possibly make. If you compare the hardness of that and with the hardness of the things which is manufactured by them, there is much difference is there. Their technology is very superior. And another thing is that what they use to manufacture this shells is only with calcium carbonates and chitin. Just two materials which we already know. These are the materials that they use to make this kind of thing. So calcium carbonate, we know that it is already available in the seawater as well as in our normal water. Our hardness of water is mainly because of this calcium carbonate deposit on the water, right? So everywhere the calcium carbonate is there. So what they do is they will excrete a protein. What this protein does is they will absorb the calcium and carbonate ions from the surroundings, and they will make a shell or a layer of deposit of calcium carbonate. Then they will again produce this kind of protein, and then they will get another layer. So layer by layer they are manufacturing. Layer by layer they are creating, and they're creating for themselves to protect themselves. So this ideology, now we can see some similarities what we were discussing about 3D printing, right? So this is a similar technology, and I'm very happy that I have a technology which is very close to biological world. Which, in fact, I think that now I will not say that our 3D printing is a sustainable technology. We also use many kind of heating sources. We also waste a lot of materials. We also we use hazardous chemicals and all the things for the 3D printing technology as well. But I have a scope. I think that there is a scope for improvement, and maybe in the future I can, when I have asked about this question, do you have any alternative? Now I maybe in the future I can able to say that yeah, I have an alternative, and that is 3D printing. So this is my expectation. This is why I like this technology as a solution, or the answer to my question, or the answer which I must answer this question, right? So that's why I love this technology. So it is similar to biomimicking. So I think that maybe in the future we will have our first sustainable manufacturing process. So that's where I want to stop this discussion, and I think time is up. So I would like to take questions if it's there. Yes, Ruma sir, it's up to you.
Hello, participants. If you have any question,
Yes, sir.
you can unmute your mic and ask, or you can type in the chat box also.
Yeah, typing will be fine, so that I can get it and I can answer one by one. Because if everybody use their mic, then it will be really difficult. Just type it and post it.
If there is no questions, then I invite Navish sir. Our
Give some
expert in
time,
science.
means maybe.
Okay.
Yeah, maybe 1 minute we will wait for any question. And do you think it's boring? Then you can come and please come and don't worry whether it's a boring. You can please say that it's boring, and I can always have improvement on my lectures, right? Otherwise, I will think that it is good, and I will keep on doing that. So it's a feedback for me as well. So please don't hesitate to tell your feedback. Okay. So I think that it was very boring and people does not understand what I wanted to say, because otherwise there will be questions. I was expecting so.
Please ask your questions.
Okay, sir. No problem. If you have any questions, yes, just give it to the feedback form, and I will be happy to answer that thing. So we can. I think since there is no question is popping up, so we can wind up the session.
Sir, Navish sir is there? Navish sir?
Yes, sir. Yes, sir. Yes, sir.
Yes, I think he is there.
I invite Navish
Okay.
sir for the vote of thanks.
So, Arun sir, it was a very valuable class. Thank you. First of all, I would like.
Okay,
Hope
thank you,
can hear
sir.
me, right?
Mm.
Okay. First of all, I would like to thank our Mount Sion principal, Dr. K. Matthew, for the valuable for providing us the opportunity to conduct this webinar. Right. So then I would like to thank our valuable speaker, Dr. K. Unnikrishnan, for the valuable knowledge he has shared with us about the 3D printing. Hope everybody has learned many things from this webinar. Right. Next, I would like to thank all the participants who have attended the webinar, those who have taken time out from their schedule period to attending this webinar. Thank you all. Thank you all for your valuable cooperation. Next, I would like to thank the coordinators, Srikumar sir, Irfan, and all the faculty members who have helped us to conduct this webinar. Thank you. Thanks a lot. Last but not the least, I would like to thank all of you for this valuable participation. Thank you. Thank you, sir. Srikumar sir. Hello. Hello.
Srikumar sir.
Are you there? Okay, so thank you. Anyway, thank you, Arun sir, for your
Okay,
contribution.
let's find out. Okay,
Okay,
thank you very
sir.
much. Thank you very much. Yeah.